Part C, again, we want to write but not evaluate an integral that gives the volume of the solid generated when r is rotated about y equals -2. So let's go back up here and look. We are looking at this region here, region R, and we want to rotate it about this line, y equals -2. So that means we'd need another point that is concurrent with that. We can label that x comma -2, and then we're going to rotate this strip. Notice we're perpendicular to what we're rotating around, so we're going to get a washer. So we can label that sample washer. Its big radius is going to be that top y coordinate, minus the bottom y coordinate, which is -2, and then the little radius is going to be this point here, which was 4 minus the -2. So we'll take this x coordinate minus this x coordinate, and we will get 6. So the setup for our integral, that volume, will be a pi times that big radius squared minus the little radius squared times dx, and we got to think about the limits. The region that's being rotated is this region R, so the furthest left we can pull that strip is -4, the furthest right it can go is -2. So my limits are -6 to -2. So, okay, for that last part, D, again we are only writing and not evaluating an integral expression that gives the volume of the solid whose base is R and whose cross sections perpendicular to the x-axis are semicircles. So if we go back up, we're going to be using this same strip here, except now we're going to be building semicircles that come off. So that means the length of this strip, which is the y coordinate minus the y coordinate, it's the same as that length we used up here in part A. We're going to take that length, and that length is going to be the diameter of the semicircle. So if we look at part D, we could draw that sample strip who has a semicircular shape with a hair of thickness. Its thickness is going to be a dx, and its diameter is going to be that length of the strip from up in part A. So we can set up our volume will be 1/2 pi times the radius squared times the thickness, and we're going to sum them all up. So that radius will be the length of the strip, which was the top y coordinate minus the bottom y coordinate over 2, because we took the whole length, which was the diameter, and we're going to divide by 2 to get the radius. So now we have 1/2 of a pi r squared times the thickness. And my limits, if we go back and look at r, that strip can go from -6 forward to -2. So that means my limits here will go from -6 to -2. And we don't have to simplify it, we don't have to do anything. Once we have that written, you're done, you're good, call it good, and stop.